comprehensive overview of ink, history, types, composition, and innovations. History of ink. Across cultures and eras, ink has been an essential medium for writing and art since antiquity. Its formulation evolved independently in different civilizations, each leveraging available natural materials. Ancient Egypt. Circa 26th century BC. Egyptians developed black and red inks from carbon soot, lampblack, mixed with water and gum or resin, often adding minerals. Chemical analyses show Egyptian inks contained iron compounds and ochre pigments, with salts, phosphates, sulfates, chlorides, and even lead added as a drying agent. Scribes applied these inks on papyrus for texts and illustrations. Ancient China, circa 2500–200 BC. Early Chinese inks were similarly carbon-based. By the Warring States period, 256 BC, China produced solid inksticks made by combining pine soot, lampblack, with animal glue, then drying the mixture into sticks. To use an inkstick, one would grind it with water on an inkstone to yield a deep black ink. This India ink, originally invented in China, despite the name, was well established by the 3rd century AD. Traditional recipes used hide glue, carbon lampblack, or bone black, and sometimes resin. The dried sticks were moistened with a brush to produce liquid ink for calligraphy. Greco-Roman, classical antiquity. Greek and Roman writers used ink known as atramentum, essentially a soot-based ink, similar to the Egyptian formula, lampblack, gyaon, gum, gyaon, water. Additionally, sepia ink derived from cephalopod, cuttlefish, ink sacs, was employed as a blackish-brown drawing ink. These carbon-based inks were the standard for writing on papyrus, wood, or parchment in the classical world. Iron gall ink, late antiquity to medieval. Around the 4th–5th century AD, a new type of ink gained popularity for its permanence. Iron gall ink. This ink was made from tannins, gallic acid, extracted from oak galls, plant growths, mixed with iron salts, usually ferrous sulfate, and a binder like gum arabic. When first applied, it appears bluish-black, then darkens to a rich black as it oxidizes on the page. Iron gall ink became the dominant writing ink in medieval Europe, 800–1500 AD, prized for its indelibility on parchment and paper. Monastic scribes and later Renaissance scholars used it for manuscripts, letters, and drawings. However, it is acidic and, over centuries, can degrade paper, ink corrosion. Medieval recipes. Medieval ink makers often guarded their formulas. One 12th century European recipe illustrates the process. Hawthorn wood was cut in spring, dried, and the bark soaked in water for days. The extract was boiled with wine until black, then combined with iron sulfate over heat to create the ink. The mixture would be stored and diluted as needed. Such recipes produced a dark, permanent ink, essentially an iron gall ink variant, well suited to quills on parchment. Oak galls, left and crystallized iron. 2. Sulfate. Right. Key ingredients of traditional iron gall ink. Medieval ink makers mixed tannin from galls with iron sulfate and gum to produce a durable blue-black writing ink that darkened as it oxidized. The printing press era. Renaissance. The invention of the movable type printing press in the 15th century, Gutenberg, c. 1440, demanded a fundamentally different ink. Quill inks like carbon or iron gall types were too runny and did not adhere well to metal type. Gutenberg's solution was an oil-based ink, a thick, varnish-like formula made by suspending lampblack, soot, in a drying oil. According to historical accounts, Gutenberg's indelible printing ink was made from lampblack, mixed with a varnish boiled linseed oil, or similar, and possibly resin or egg white. Soon, printers formulated inks from soot, walnut oil, and turpentine, a viscous ink that would stick to metal type and transfer cleanly to paper without blurring. This marked a shift from water-based to oil-based inks in Europe. Print inks enabled the mass production of books. By the 16th, 17th centuries, printers were skilled in preparing pigment, oil mixtures, and even colored inks for illustrations. Industrial era, 18th, 19th centuries. As chemistry advanced, ink formulation became more scientific. The 18th century still saw ink made in small batches, but by the 19th century, the Industrial Revolution introduced synthetic dyes and mass production of inks. Aniline dyes, derived from coal tar, first synthesized in the mid-1800s, allowed creation of vibrant colored inks beyond the traditional blacks and earth tones. Ink manufacturers could now produce blues, purples, magentas, and greens, using synthetic dye compounds that were more consistent and bright than natural dyes. For example, methylene blue, fuchsine, magenta, and other aniline dyes began to appear in writing inks. At the same time, the growing printing industry, newspapers, books, packaging, spurred development of specialized inks, faster drying formulations for high-speed presses, and new types for processes like lithography, invented 1796, and rotary, steam presses, By the late 19th century, ink making was an industrial science, with factories cooking oils and resins, grinding pigments in large mills, and packaging inks for commerce, instead of each printer mixing their own. Modern era, 20th centuries. The past century brought an explosion of new ink types to suit various writing and printing technologies. Fountain pens, late 19th century, required free-flowing, water-based inks, leading companies like Parker and Schieffer to develop non-clogging formulas, e.g. Parker's Quink in 1931. A quick-drying fountain, pen ink. Ballpoint pens, invented 1938, popularized mid-1940s, introduced viscous oil-based inks, see details in types section below, that would write on many surfaces without blotting. Typewriters and ink ribbons, early 20th century, used cloth ribbons, impregnated with oily ink that would transfer under pressure. Printing saw the rise of offset lithography, early 1900s, with petroleum-based or soy-based inks, screen printing inks, including plastisol for textiles, and later inkjet printing, 1970s, 80s, which uses fast-drying water-based dye or pigment inks. In the late 20th century and into the 21st, specialty inks and digital printing emerged. UV curable inks, solvent-based inks for wide-format printers, 3D printing inks, and more, discussed later. Throughout its history, ink transformed from simple mixtures of soot and gum to complex formulations engineered for specific applications, yet the core components remain recognizable: a colorant, pigment, or dye, and a vehicle, liquid carrier or binder, sometimes with additives to improve performance. This continuity and change in ink technology will be clearer as we examine the types of ink in use today and their compositions.